Good morning, dear students. In our previous video, we had discussed about the row elimination technique. For the same example, I am showing you with implication table method how can we reduce the redundant states or eliminate the redundant states. This is called as implication table method. So what we do here is at every state we see how we can optimize. So here always when we are traversing, we will traverse from A to B, A to C like this. We will never go backward tracing is not done. B to A, C to B, nothing is done like that. It is always in the forward direction. Okay. So for that what we do is I will eliminate the first row. I will start with the second row. Okay. B, C, D, E, F, G. So first row is eliminated and last column is eliminated. Last column is eliminated. So the optimization starts from the initial state. You can see that. Okay. So I have eliminated the first row and the last column. Okay. Now this is my implication table. Now what is the funda here? The same concept. Whenever I am checking for the output states, from each state I should check whether the output matches. So the first step here is if the output does not match. If the output does not match, I am just representing with a double cross. Okay, then I will tell you what is that single cross. Now I have to check from each state. Okay, from A to B, output is matching 0, 0. A to C, it is matching. A to D, it is not matching. A to E, it is not matching. F and G, all these are not matching with respect to A. So only A to B, A to C is matching. The rest are not matching. So I will put a double cross which indicates that output does not match. Similarly, I will do from B. So B to C, output matches. Same thing, B to D, E, F and G, it does not match. So I am marking with a double cross. From state C also it does not match. C to D, C to E, C to F and C to G does not match. Next coming to D, from D to E output matches, D to F, for this all the things match. Even for E everything is matching, even for F outputs are matching. So this is our first step. First step, whether the output is matching or not. If it is not matching, from that transition you will mark with a double cross. This was your first step. The second step, you will understand why I am telling you have to mark the outputs, because if the outputs does not match, you will never check for the transition. Okay. Now we will check for the transitions only for the blocks which have the same output. Now if I check from A to B, okay, A on 0, it is going to A and C. So I will write AC, comma, or input 1 from A to B, it is going to B and D. Okay, similarly from A to C if I check, it is going to AA, comma, BD. Okay. Next, that's all. I need not check for this. I need not write the transitions because the output does not match. That is the first criteria. Now, from B to C, it is CA. But I will write it as AC because we will never do transition. We will never check backward direction CA. I will check it as AC. Right? Then DD. D. Next one is from C. Nothing is matching for the output, so I need not check any transition. From D to E, it is EA and FF. So I will write it as AE, comma, FF. Next, D to F, it is EG, comma, FF. Then from D to G, it is AE and FF. AE, comma, FF. Then from E to F, this is E to F, that is what I am writing. From E to F, it is AG, comma, FF. Then E to G, AA, comma, FF. Then from F to G, you have to see this, F to G, F to G, it is AG, comma, FF, AG, comma, FF. So, these are the transitions what I have written. Now we have to check whether the transitions are valid or they are redundant, whatever. So, how do we check? The next step, once you write the transitions, what you are supposed to check is, you are supposed to check whether those transitions are valid. Now, if I go to the first block, I have AC. What is AC? You have to go to this AC block here, whether you have some valid transition. If you have, this becomes valid, but it should work for both the transitions. So A to C, when I check, there is some data, no into is marked, so this is valid, but I have to check for the next transition, BD. If I check B to D, you can see B to D, it is not valid. So this transition also becomes invalid. So it is not a valid state. Next. So this is gone. Now A to C, when I come, I have AA. AA is self loop. So it will always be true. But the next transition you check, it is B to D. B to D again is not valid. So this also is not a valid transition. Next, I will come to AC. A to C, if you check, it is not valid. See, it is cancelled. If the first one itself is not valid, you need not check for the second one. Next, coming like this, here nothing I have. For D, if you check, I have A to E. A to E, if you check, A to E is not at all valid. So this also will go away. Next, E to G. E to G, if you check, you have some valid transition. So keep it. Then F to F, this is self loop. So this will always be true. So this will be retained. Next I have A to E. A to E, if you check, nothing is valid in A. So this one becomes invalid. Next, from this E I am checking A to G. A to G, A from A, nothing is valid. Okay, so this also is cancelled. Next I have AA. AA is a self loop, it will always be true. And I have FF. This we call as the equivalent states. So it will always be true. Okay, so this is a valid state. Next, coming here, I have AG. Anything with A is not at all valid. So this will go away. Okay, after doing all this, which transition is valid, we are left with only these two. Now, the second round I should check whether in my further this one, whether this was cancelled or what. Now I will check for EG. E to G still, E to G still remains valid. So this is a valid state. Okay, and this is a valid state. Only two states we got as valid. But from this, how do I infer what are my equivalent states? So for this, I will be drawing a partition table. Okay, so how I write this partition table is, first I start from this last state F. From F I don't have any transition, so only F will be there. Then I go to the next state E. From E I have a valid transition EG. E to G I got this transition. Correct? So I will write this EG. What is the meaning of this EG? It means that E and G both are equivalent. Okay? E and G both are equivalent. So I have to retain one state. Usually I will retain E. That we will see later. Then next I will go to D. From D I have one valid transition. What is it? So I will write down all these previous ones. E, G, F, and then from D I got D to F. So now if you just check here, F is already here. So F, D and F are valid and equivalent states. So I can eliminate F. So D will give me EG and DF. Okay. So now I will go for state C. When I go for state C, nothing is valid. So I will retain only C. So I cannot eliminate that state. I have to hold it. Next, if I go to B, B also you see nothing is valid. So I have to retain B. B, C, E, G and D, F. Okay. Now I will go to the last state, that is A. So in A also I don't have anything valid. So I will write down A, B, C. Then from E to G, E and G both are equivalent. So I can retain 1. So I will retain E, because usually we don't do the backward transition, right? So I will retain the earlier one. Here also I will retain D. So I got 5 equivalent states A, B, C, E and D. If you just remember the previous technique what we did for the same example using row elimination method, we got the same 5 states. So this is how implication method is used for eliminating the redundant states. Hope this is clear to you all students. Thank you. Happy learning.